Hey guys, I just wanted to do a couple of these with you. I posted the answer key, but I figured some of them were a little bit trickier than the others. Again, I'm only going to do a couple, so I'm going to go straight to number 4 here. This one was a very nice, tricky question. You should have seen this in your other factoring as well. So here you're going to do the GCF. So GCF 6, 12, and 6 have a common factor of 6. So we're going to go ahead and factor that out. So here I'm going to factor out 6. They don't have any of the x raised to any power that's the same, so I can't take any of that out. So really we're just left with x to the 4th minus 2x squared plus 1. All right, so now here you should have seen this somewhere, and this is why I'm addressing it, because these ones are a little bit trickier. So if you see this trinomial right here, it is factorable, but you have to start kind of think a little simplified. So what do I mean by that? What I mean by that, if we take the same thing but just do x squared minus 2x plus 1, if I give you that to factor, you can factor that. Simple, right? So something that multiplies to 1 and adds to negative 2. Oh, that's easy. It's just negative 1 and negative 1, right? Great. We're going to use that same mentality, but instead of x minus 1, notice how the exponents are just doubled. So instead of x squared, it's x to the 4th. Instead of x, it's x squared. So basically everything's doubled. So instead of x minus 1, we're going to use, well, the 6 still comes along for the ride, we're just going to do x squared minus 1. All right, so again, if you do not see it, you're going to take these two and go ahead and expand them. So go ahead and FOIL. You're going to get that x to the 4th, x squared times x squared minus x squared times negative 1 is going to be negative x squared. Negative 1 times x squared, well, that's going to give you another negative 1 x squared. Negative 1 times negative 1 will give you the positive 1. Combine like terms, and there you go, you have that original. All right, so that is the trick to that. So the trick really is to just simplify it a little bit. See what you've already been able to do, because you can do this right here. We've done those simplified versions of factoring, and in this case, the only difference is that instead of x squared, it's x to the 4th. All right, so I'm going to go ahead and just erase that part right here so we can go ahead and graph. All right, so let's take a look at what we have. So we have x squared minus 1. You would think that we're done, but we're actually not. X squared minus 1 is a perfect square. This is a we can simplify this. So remember, your perfect squares are 1, 4, 9, continue on, etc. You can factor difference of a perfect square. So this is a difference of a perfect square. So we can go ahead and factor that a little bit more. Now, the perfect squares, the difference of a perfect square is nice and easy because it's really just going to be x plus x minus, all right? And the number that you're missing right here is going to be whatever your perfect square is, the square root of your perfect square, all right? So in this case, the square root of 1 is 1. So we are going to get 6. This would be x plus 1, x minus 1. And we're going to do this twice because there's 2 of them. So x plus 1, x minus 1. All right. Now, this is really the real broken down, but I'm going to go ahead and combine, because this is how you'll see the multiplicities come into play, all right? So that factor and these two factors are the same, so we can square them, and then we can see how the multiplicity of 2 comes into play, all right? So y equals 6, again, it's just coming along for the ride. X plus 1 times x plus 1 is x plus 1 squared. X minus 1 times x minus 1 is x minus 1 squared. All right, so that's your factored form equation. Your roots, you just take each one and set it equal to 0. All right, now don't forget to state your multiplicities. Okay, so again, take each one, set it equal to 0. It's just whatever's inside of the parentheses. Okay, so in our case, so each part, wherever you see an x, that's where you're going to solve. All right, so it doesn't necessarily mean just wherever you see parentheses. In this example, it's where you see the parentheses. That's where the x's are in. All right, so solve x equals -1. So here x equals -1. Multiplicity of 2 because of that 2 exponent. So parentheses m2, so that I can show that I know that there's a multiplicity. That means there is a bounce when your x-intercept is at -1. Similarly, when we solve for this one right here, that's going to give us a +1, and again, multiplicity of 2. Your multiplicity is really the same as your exponent, all right? So multiplicity is the same as your exponent. Okay, the exponent tells you how many factors there are. The multiplicity tells you what it'll look like in the graph. There are two things that have the same numerical value but mean two different things when it comes into context of your equation and graph. You need both of them so that you can distinguish which type of equation you're going to have or which type of graph you're going to have. All right, your y-intercept, oh, that's easy in standard form. It's your last constant number. All right, so again, you can plug in 0 for everything. So 0, 0, wherever you see x. All right, so this is just going to be 1 squared. That's 1. -1 times -1 is just 1. So 6 times 1 times 1 will give you 6. Okay, and that is it. And behavior. Okay, so let's go back to the basics. Your leading coefficient is right here. And again, you can do this in standard form or factored form. Standard form is actually easier to look at. So I'm going to go ahead and erase everything so that it's nice and clean for us. So your leading coefficient, again, is the first number. Is it positive or negative? It's positive. Okay. So we do need to know certain things about this polynomial before we can write its end behavior. So everything that I'm writing here is so that I know the end behavior and what the graph is going to look like. All right, so this is not your end behavior answer. This is what you need to know to get your end behavior. All right, your degree is 4, so your degree of a polynomial is the highest exponent. 4 is an even number, so you have an even degree that's positive. So that means it should end in the same direction. It's positive, so it's going to end positive. So your answer for your end behavior is going to be as x approaches -infinity. I like to write it from left to right, so this is from the left side. All right, f of x goes to +infinity. And then on the right side, f of x is still going to +infinity. All right, so let's plot things that we know. So we know our roots are at -1 and +1. We know our y-intercept is 6. All right, and we know that it ends up. So up. So we know it hits -1 because it has a multiplicity of 2. It bounces off. It doesn't go through -1. It bounces off -1. It has to go back and cross your y-intercept at 6. Comes back down to +1. But because it has a multiplicity of 2, it doesn't go through 2. I mean, it doesn't go through 1. It goes and bounces off 1. And there is your graph. Oh, look, it looks gorgeous. So pretty. All right, so the next one I would like